Let's go through a couple examples to improve our comfort with the remainder theorem. In part 2.25a, we'll divide the given polynomial by x plus 1. Instead of writing the synthetic division here, let's evaluate p of x using the 0 of the divisor. The 0 of x plus 1 would be minus 1, because minus 1 plus 1 makes 0. We'll replace every instance of x with negative 1. Be sure to use brackets. We want to make sure we perform the exponents before the multiplications of the coefficients. Here, if you evaluate this by hand or using a calculator, you should get a value of negative 12. We can confirm this using our graphing calculator. Simply type in the polynomial given. Then, using the trace function, check when x is negative 1. You should find a height of negative 12. You could also find this value by looking on your table of values and scrolling up to where x is negative 1. In part b, we will divide the polynomial given by 4x plus 1. Now here, we are not in the form of x minus a, but our remainder theorem will still work. We must ask ourselves, what is the 0 of the function 4x plus 1? Many students would like to write this as 4x plus 1 equals 0, and then solve to isolate x. You should find that when x is negative 1/4, the expression 4x plus 1 gives a 0. So we will evaluate p of x for negative 1/4. Replacing every instance of x with negative 1/4, we evaluate to find a 0. This would mean that negative 1/4 is an x-intercept of the graph and a 0 of the function.